Good afternoon, everyone. Before we get started today, we have a quick poll while we wait for all our attendees to join us. How effective do you think we are at listening? Perhaps under 50%? Maybe 50 to 70%? 70 to 90? 90% higher? We'll wait a couple of minutes and if you'd like, please fill in the poll. Okay. So, okay, we can see quite a few people. Yep, 50 to 70%. Well, would it surprise you to learn that research has shown that we effectively only listen 20 to 50% of the time? In effect, every conversation you listen to, you're only hearing on average 50% of what's said. Scary, isn't it? So when it comes to audio records in business, why are we still manually listening to them for compliance and legal requests? My name is Angela Bunting, VP of eDiscovery here at Nuix, and today I'm joined by Pete Fetzer, Senior Solutions Consultant. Welcome, Peter.
Hi, everybody.
And we're here to talk to you today about some of the myths around using automatic transcription technology on audio files. Just as a bit of housekeeping before we get started, if you have any questions as we're going through, please feel free to type them into the chat box and we'll have a section at the end where we can hopefully answer them for you. So let's get started. The 4 key myths we want to discuss today are automatic transcription is slow. It's just as easy to have someone to listen to it. Creating indexes from audio files are large and slow to search, so is it worth the investment in time? Listening for key terms is more accurate. And automatic transcription doesn't recognise proper nouns or key terms for my business, so why bother? Recorded voice data is becoming more and more prevalent today in business records. Not only is the way we work today impacting this, but also increasing regulatory requirements to ensure proactive compliance stances and practice. Corporations in heavily regulated environments are on the cusp of what's becoming quite a challenge. So, as another quick poll to our audience, can you tell us if you record business or voice as a business record today? So, couple of answers there. Yes for compliance, yes for record meetings and trainings perhaps, just voicemail perhaps, or no, we don't process voice data, or I don't think so. We'll wait a couple of minutes while our attendees fill in that poll. Okay. You can see quite a few people are still recording meetings and trainings as well as compliance. Wonderful. So the first myth we want to talk about today is really that automatic transcription is slow. Pete, transcription technology isn't new and has previously been quite slow, right?
Yeah, look, that's right. Transcription technology is not new. It's been around for a while. And it certainly is a lot faster now, but how about if I start with a quick history and perhaps I could set us up for some common terminology for today. I'd say in history it's a very complicated field and there's a lot that's been going on in the last part of the 20th century. But what I would say is that it really gets going in the 1990s. Actually, we've got a good slide here, so we can actually see there's a lot going on. We see, Bell did a lot of work in the 50s, and DARPA really started getting into it from about the 70s onwards. But there we can see Dragon comes into it in the 90s, and that's where, Dragon had been getting going since the early 80s, but they really don't start to solve converting continuous speech until the 90s. And from the 90s onwards, that's where you get a number of different software solutions coming onto the market, and they're all tailored to solve particular problems, and here we are today. In terms of perhaps basic terminology, well, I think we'll make mention of 2 approaches to speech-to-text software. One where the software records individual phonemes, and we'll call that the phonetic approach, and another where it records the whole words or full-text transcripts. And it's a bit confusing, but we usually label that automatic speech recognition. An example of the phonetic approach would be to, say, record my name as 2 sounds, P and Ta. But automatic speech recognition, that's going to generate a full text transcript and generate a word, Peter. And I guess, in addition to talking about these two approaches, phonetic and automatic speech recognition, we'll also be talking about, just manually listening to audio files instead of using software. And yes, before anyone asks, there actually is a fourth area in speech-to-text software, and these are the sorts of deep learning neural network approaches. So the kinds of things that you might see with Apple's Siri or Google Assistant and Amazon Alexa tools. Not really relevant to us today. Those tools really have been aimed at a particular use case. So consumers using mobile phones, short commands, small queries. That technology hasn't really been tuned to the sorts of problems that we're talking about today, which is, processing corporate audio records.
And Pete, really, they've only just sort of cracked that nut, sort of, July through to October last year, and the results are pretty promising. So I'd say that we'll probably see that in sort of 3 to 5 years, wouldn't you think?
Yeah, definitely. I mean, with speech to text, it really is a case of watch this space. So I guess now that we're all experts in this field, thinking about whether it's slow or not. And, I thought it was interesting to talk about when I first joined Nuix, we used to spend a lot of time telling people how fast Nuix was. I'm talking here about the traditional Nuix data indexing technology. But it was interesting, customers weren't as enamored with the speed as we were. They were more interested in, say, breadth of file support or funky ways that they could automate their workflows. So it was interesting when, we started talking about speech-to-text technology and all of a sudden, we're talking about speed coming up as a primary talking point. Was it as important? And I think that, speed really is a primary talking point here. And the thing that I'm getting at here is that many organizations, they have a mountain of audio files. They've got hundreds of thousands of audio records recorded, or if not millions of hours. And, we're talking about customer interactions, we're talking about voicemail, records of financial trades and so on. So, if the intent is to process, the mountain of audio, we might think about what different approaches might look like. Thinking about here, talking about the mountain of audio, if we think about how long it's going to take to process an hour of audio files with different methods, the first method that we might think about is, sending it out to a transcription service, having someone sit down and actually transcribe it. And interestingly enough, it takes 4 hours of manual transcription time to process 1 hour of audio. Another method that we might think about is someone sitting there and listening out to the audio, perhaps in the background sort of thing, so listening out for keywords and so forth. So manually listening and identifying content that's relevant. We might say that an hour of audio is going to take an hour of listening time. And I think if you move to the next bit of that slide, Ange, you'll see that pops up. And then lastly, if we think about how fast a server a speech-to-text software can take to process an hour of audio, in comparison, we're thinking about 36 seconds. So speech-to-text software much faster than manually listening or using manual transcription services. But there's actually another way to present this information. I mean, imagine if you were an organisation that had 100,000 hours of audio. If we were thinking about manual transcription and the fact that we can process, 1 hour and 4 hours and that sort of thing, to get that 100,000 hours of audio, we'd need to organise 50,000 days of someone sitting down. And if we compared that to, say, someone manually listening to the 100,000 hours of audio, then that's going to equate to, I think it's about 12,500 days. So, it's not, these are rather large things thinking about resourcing. But if we compared that to a server that can process 100 hours of audio in that 1 hour, and also, given the fact that we can run a server 24 hours a day, that means each day we can hit 2,400 hours, which means instead of 50,000 days, we're talking about 42 days. And I realise this is a little bit of an unfair comparison, because if you send this out to a transcription service, obviously they're going to employ more than one person. But I think, given these numbers, 50,000 to 42, you can see that it's rather a large difference. So, yeah. Is it slow?
Yeah.
No, I don't think it is.
Yeah, that would also add the cost is another factor. You know, when comparing manual and software approaches, Pete, you know, I mean, it's pretty well known that the cost of running a computer for an hour is a bit less than running an employee for an hour. But especially, you know, if you can effectively transcribe audio at 1,000 times the rate of a person can transcribe. So you said that it's faster today and that you can process 100 hours in an hour. How do you get the technology to get to that point?
Yeah, actually, so that previous slide that we had talks to that, and basically it's modern technology. So, you know, what we've noticed in the last decade is that speech-to-text software, you know, starts to take advantage of, you know, modern advances with computers. You know, and two things really stand out there. One is going to be parallel processing, and the other would be data models. So here we have a slide that talks about parallel processing. So, you know, 10 years ago, a lot of computing was still done on a single CPU, but parallel processing doesn't just mean from single core CPUs to multi-core CPUs. You know, it also means taking advantage of the massive number of cores available in modern GPUs or graphics cards. Basically, modern technology gives us a much faster platform to do stuff on if you take advantage of parallel processing. I mean, we can certainly run software on laptops and VMs and whatnot, but when we really want to start putting the foot down on the accelerator, that's where we provision high-end servers with, you know, dual Tesla cards so we can take advantage of GPU processing. And that second point that I mentioned in terms of data models, if we use a simple definition of software, taking input, makes a decision and pushes out output, you know, a data model improves things because that hard work of complicated decision making has largely been done, you know, up front by building a data model. You know, it's quicker to run through a pre-built decision tree or support vector machine or whatever data model is used, as opposed to running a more traditional piece of software. So yeah, with modern technology, automatic transcription, not slow. You know, we've seen some really amazing improvements in processing speed.
Thanks, Pete. That kind of leads us nicely into our second myth today, that indexes created from automatic transcription technology are large and slow. Do you have some thoughts around that?
Yeah, look, I don't think automatically transcribed indexes are any different to any other indexed text. You know, in the same way where we might OCR an image file and we store the generated text, a text transcript is not large in comparison to the size of the audio files. You know, and there are approaches where you don't have to store indexes. You know, software that performs keyword spotting rather than transcription, or, you know, if someone's manually listening to audio files, obviously there's no index required there. But text transcripts are tiny files; they're not large at all. And in terms of being slow to search, not at all. I mean, technology has been solving fast searches for a very long time. You know, for example, my laptop, if I have 1 million transcripts, I'll get a response from that when I search it in a blip of a second. You know, in fact, we've actually got a setup here in the office where we've got 100 terabytes of indexed data, and I get a search result coming back from that in about 3 seconds. Text searches are very, very fast. But, you know, I think this actually leads on to really another great point. We can actually start treating full transcription with the same tools as you can with traditional document indexing methods. So, you know, and actually that's an important difference between those two speech-to-text approaches mentioned earlier. Software that records phonetic data only, you know, the phonetic approach, that may not be able to take advantage of fast text search indexes. So look, full text indexes are not large and they're certainly not slow.
Very, very similar to, I guess, like the analogy you said, OCR text, and they're only a couple of kilobytes or even a megabyte for a very, very large file. So it's only a small fraction of the actual file itself.
Absolutely.
Okay, well, before we head into our next myth, we have another quick poll for the audience. So how are you currently reviewing your voice data? We'll give everyone a couple of minutes to just fill that in. Are you manually listening for your key terms? Are you transcribing those that are in scope when you've got a request or a compliance notice? Are you automatically transcribing? So are you already starting to adopt some technology in this area? Or are you transcribing everything so that you're upfront and ready? Okay. Just give everyone another minute. Okay, we might move on to our next myth. Thanks, everyone. So, our next myth, listening for key terms is more accurate. Well, I think the start of this webinar proved that in reality, while we think we're doing a fairly good job listening, we often aren't. So even if our transcribed text, which is most likely going to be around sort of the 80% mark, depending on the quality of the recording, of course, it's still often going to be better than listening to the file manually, especially if the listening's being done at the same time as other tasks. But there's more to the story, though, in terms of accuracy, Pete.
Yeah, look, I think a really important point to consider is accuracy in relation to the amount of effort required. You know, by that I mean how much audio you have, how much audio you actually have to process. It's a good point to raise. I mean, advantages of different approaches come down to what you are trying to achieve and what you have to do. I think having someone manually listen to audio to pick out content, I think that's perfectly fine. If you have a tiny amount of audio and you just want to find content in relation to, say, one or two topics, but the moment you start moving away from tiny amounts of audio, I think the game changes. It gets harder to marshal large numbers of people to manually listen to audio. As you point out, we've had conversations with a couple of organisations where people will listen to audio in the background while they do other work. That's kind of a recipe for missing stuff. With larger amounts of audio files, using speech to text to build full text transcripts of audio brings with it, a lot of advantages over manual listening or over software approaches that utilize keyword spotting. So the kind of advantages perhaps I'm thinking about there, you can just, with a full text transcript, you get to treat audio as just another information source. You can run the same analysis tools across your audio as you have with document repositories, for example. Or if you have futuristic trend analysis tools, you can throw your audio content in with other content sources and take advantage of those tools. Maybe a second point, having the full text transcript means that content's available for multiple use cases. So thinking about that person manually listening to files, if they're only interested in one or two topics, that's absolutely fine. But what happens if you've got future investigations? What happens if you're running an investigation, you're analysing these audio files, and the game starts to change as you move through it? And actually, that's a great slide that you bring up there in terms of yet another third point where we think about automatic speech recognition comes with other tools such as emotion analysis, customer sentiment, and so forth.
Great, and as you pointed out, we can see some of the examples on the analysis tools or different trending tools that you can use when it comes to sentiment, but also in terms of things like key terms. So we often hear stories of people trying to listen for key terms in relation to a notice or a request that they're doing, or just perhaps as proactive compliance. And I guess in our industry especially, we sort of see a lot of people are getting very, very crafty these days, and what you think you're looking for isn't always the language that's being used in an organisation. So by having that text, you can start to see sort of the terms and the phrases that are trending across time, which perhaps is leading to different behaviour or perhaps misconduct that you didn't think was actually happening.
Yeah, being crafty is good, I think. But to go back to accuracy, look, it's a really interesting topic. I was thinking that if someone were to ask me how to start investigating speech-to-text technology, I'd say certainly you could spend time looking at different technologies and vendors and so forth. And as a vendor of speech-to-text technology, I would encourage that. But I think it's missing out on a really important aspect, and that's looking at how your organisation is recording audio records in the first place. If we go back to our earlier point, Ange, about comparing OCR technology with speech-to-text technology, OCR really got good once we saw improvements in the quality of scanned images. We used to run OCR on scans of photocopies and so forth. But when we started processing, when we started OCRing direct digital feeds from fax systems, for example, OCR quality really starts to improve. In terms of audio records, if your organisation is putting a single microphone into a room and recording the background conversations, chances are you're going to get a poor result from speech-to-text software. You've got background noise, you've got multiple people speaking over one another. It's often impossible to identify who is speaking. instead of solely focusing, on speech-to-text technology, I think you'd actually get a massive improvement by, say, replacing background microphones with individual microphones, such as headsets and so forth. I mean, that not only improves the quality of the audio record, but you might actually be able to automate the recording of who's actually speaking at the time.
So that's the far field and near field microphones, right?
Yeah, exactly. With audio technology, you might start hearing terms like that. Far field microphones, that just refers to, say, background microphones, whereas a near field microphone is something that's recording, say, close to a speaker, something like a telephone or a headset, perhaps.
So we've delved into a few extra points there, and I really like the point of OCR because I think it is a predictive technology as well, just like automatic transcription. And it had sort of a similar path in terms of getting adopted. And as you said, it was very bad at the beginning. And of course, yeah, as we started to get more documents that print off beautifully and digital faxes, that became a lot better. But it starts at, even the most perfect document, 97%, and degrades very seriously from there. And I guess like audio, it doesn't pick up every word. So it's sort of a great analogy to go back to, that one that we've known for a long time and one we do QA on. So that brings up, I guess, the point of QA and being able to accurately measure, or getting into how much audio you need to process.
Yeah, I think we're going to talk about QA later in the webinar and stuff. But I think when people do ask us about accuracy, I think the point that I always like to make is that you've got to think about what's in front of you. And I mean, if speech-to-text software gives you an 80% accuracy rate, but for a few percent of the effort, look, I think it's really worth considering and investigating.
Great. And accuracy is very much affected by the quality. That audio, it needs to be good quality in the first place. So, considering good quality audio is something they should consider.
Yeah, absolutely. That's right. I mean, look, if you have to process legacy audio records, then yes, that's what you have to work with. But if you're concerned, say, about changing expectations from corporate regulators, and you want to investigate managing corporate audio records overall, definitely look at that input part of the equation about how audio records are being recorded by the organisation.
And I think one last thing, Pete, that perhaps you could touch on quickly is white space. It's something that we see quite a bit in audio.
Yeah, I've always thought it was interesting that I haven't seen. I mean, one of the problems that people like to look at is that they'll have a mountain of audio files, but it has been that sort of far field microphone recording, and what they want to focus on, they want to be able to drill on where things are actually being said, because if they've got a microphone that's been running for the last 24 hours, people may only be speaking for a small part of that. And rather than having someone sit there and listen to what the faint white noise at the background, running that through software to actually pick out this is where someone is speaking, that can be a pretty cool use of the technology.
Great. So, Pete, on to our last myth. But automatic transcription doesn't recognise proper nouns or key business terms. So would it be right for my business?
That's a really fair point. It's a fair point, and I'll get into it in a bit, but there are approaches that mitigate the issue. So actually, if I just explain that issue a bit more, so automatic speech recognition, that works by using large dictionaries of words, and basically any word that's transcribed, that must exist in the dictionary. If you have a strange place name or a strange keyword in the audio, it won't be transcribed correctly if it doesn't exist in the dictionary. But that said, solutions exist where the dictionaries are extensive, and they do include business terms. Data models are tailored for particular industries. For example, we might use a data model that includes terms used in the health industry, or another data model that's tuned for the finance industry.
So you mentioned that they're extensive, Pete, these dictionaries. Can you give us an indication of how big they are, say perhaps for Nuix Voice?
Sure. So, well, traditionally, a lot of data models are traditionally around the 50,000 to 100,000 word mark. Nuix Voice, we use about 125,000 words for one of these typical models.
Great.
But look, I think the original point still stands. It's an issue that does crop up, but we have additional methods to cope for. Example, we get good success with running QA over the output to identify phrases that look a little odd. I think we actually could have an example of an odd phrase coming up in a sec. If we know that there are key terms, though, for example, we'll check them to see if they're in our data model, and we'll plan accordingly if they're not. So this example that we've got here, you wouldn't actually get the result because I know that the words that this actually reflects are in our data model. But for example, if we saw something like this, it does kind of stand out because it doesn't really make sense. But once we do some QA and we see this, we might be able to swap it with what it actually should be. So I imagine you've all probably worked this out already, but really that should be financial instrument. And we've got tools that once we do some QA, we'll identify these strange phrases like that, we'll swap them around with what they should be, financial instrument, and we can update and fix the transcript like that. So yes, look, proper nouns and so forth, it is a thing, but there are things we do to improve the transcription.
Great, and I guess getting back to that OCR analogy again, it's very similar in that same line that you will see these phrases repeat and repeat, or acronyms that perhaps
Exactly.
haven't transcribed the same way, and they will be the same as you go through. So
Yeah.
I guess we didn't quite bust that last myth, but it certainly sounds like it can provide enough results to work with. And it does depend what you're looking for and how you tune the system.
Yeah, that's absolutely right.
Excellent. So, Pete, how would you summarise our 4 myths today in conclusion?
Well, so what do we have? So we had 4 myths. Myth number 1 is automatic speech recognition slow? And the answer is no. The second myth was, are the indexes overly large and slow to search? Well, they're definitely not large and definitely not slow to search. Our third myth, that was, is automatic speech recognition, is it accurate? Well, look, yes, on a very small sample, I think a person will still do a great job. But remember that you have to balance this against the quantity of audio. We see a lot of organizations tend to ignore their audio records where they have a lot of it, and that's simply because it's just hard to process. It's a question of scale. When you balance the slightly lower accuracy against the ability to process mountains of audio records, look, I think it becomes a really compelling thing to investigate further. And for our fourth myth, does automatic speech recognition, does it pick up on unique terms associated with your business? Yes, that can be an issue, but look, checking whether your provider has a data model that is tuned for your industry is a really good thing. And being aware that some time spent with QA in the output, that can lead to some really vast improvements with the result.
Fantastic, and certainly, I guess that balance of is it something that you can use straight away when it's done, or as opposed to having to wait for it to be transcribed, or actually sitting there and trying to listen to it? That sort of balance certainly comes into play. Well, hopefully
Yeah,
today we've settled some of the myths that you might have had around automatic transcription and how it can help you understand your voice data better. Do we have any questions from the audience? And it does look like we had a few through the webinar, so let me pick up those. Okay, so we've got a good one here in that does the processing of audio require the system to learn to improve accuracy, specifically around abbreviations? So I think we touched on that a little bit, Pete.
Yeah, it's interesting, and actually, when we went back to, early software, things like Dragon, you couldn't actually start using those until you had trained the system to understand your accent and the way that you speak and so forth. With Nuix Voice, for example, and I should say that there's still software out there that require you to train the system to your voice. With things like Nuix Voice, no, we don't. Those models have been built to understand. Well, the mainstay has been around American English, Australian English, and UK English, and they're working on bringing in new languages all the time. I think they've been working on Spanish for the last year and a bit, for example. So you don't train the system. These really are, you throw the audio records at this stuff, and what you get out is the output. That said, it's if you are, for example, working in India and will the software understand Hindi out of the box and understand certain dialects? Chances are it won't. It depends on whether that software provider who's actually built a model for that language. So that's actually a good question to ask when you start investigating this stuff and you're talking to a vendor, you know, checking what languages and what sort of dialects you actually want to work with.
Great, and I think that also answers another question that's just popped up is what the dialects that Nuix Voice supports, and you touched on that quickly in that we have 3 models or 3 English models at the moment, which is Australian, UK English and American English, because of course the nuances there are quite different, and with the view that we're bringing on some new models soon.
Yeah, that's right. I mean, in terms of Chinese, in terms of Hindi, say for example, it does take time to build these data models, and it's time because we need to capture a lot of information in terms of, you know, it's not just listening to the audio. We need to get very exact and a very specialized way of actually taking the text that goes with those audio files. But it's one of those things that if someone asks us, we'd like to support this language, then it becomes a conversation around, you know, the sort of time taken and the cost of building a data model specifically for that language.
Great. Now we've had another question. How widespread is the use of audio as compliance in Australia? And you know, I think that probably almost hints to the regulations around that. Pete, did you want to comment on that?
Yeah, how widespread is it? That's interesting, because I think it's not as widespread perhaps as other areas in the world, and I'm thinking here about just the regulatory framework, well, in Australia specifically. You know, we see regulatory changes happening in the UK and in America with Dodd-Frank, with UK MAR, MIFID, and so MIFID 2, I should say, where they're specifically saying, you know, you have to record audio records. We will ask you for audio records, whereas in Australia there's no legislation or very little in the way of rules to say you must record audio in certain circumstances. It's bundled up with, say, the Corporations Act and books and records. That said, you know, I'm aware that ASIC has asked organisations for audio records, but it's been a case of, you know, if you have them sort of thing. If that starts to change, if you get more regulatory compliance coming into Australia, then I think that will, you know, that will certainly have an effect on people and thinking about how they record audio records.
Okay, just popping back to your earlier question, we've had someone put in a little appendix that I think is quite good, and they've asked, does it recognise when some foreign language words are thrown into the mix of English? Or if we have a few foreign language audio in the midst of, you know, 100, tens of thousands of English audio. And I guess that analogy is very similar to those that for OCR. If you are OCRing in a language, say English, and you pop in a couple of other, you know, you might have some Chinese words, or you might have some Cyrillic words or something, it actually will try to do its best to match that based on what it's heard or what it saw when it was OCRing. But because it's not recognised in that model, or in that OCR model, say, it won't pick it up, and it's actually very interesting to watch. If you OCR a document that way, you'll either get what I commonly term as Martian, or it's just gobbledygook, some characters. So it's very similar in automatic transcription, Pete, isn't it? In that it will just substitute what it thinks it's heard.
Yeah, that's right. And funnily enough, I was actually mucking around with something like this. It wasn't a very good test because I was only using a very small piece of data, a small piece of audio. But what was happening is that the engine would come out and give you a kind of an English phonetic, you know, they'd present some sort of English word for, you know, the foreign word. And then I was fixing it up by, you know, using those tools I mentioned before, where you take the funny phrase and you actually swap it with what it should be. So, I mean, it wasn't that great a test because it was a very small file, but that's what I imagined that I would how would I approach that if we didn't have a data model for that language. I'd be looking for those funny phrases, and then I'll be swapping them out for, you know, what it should be, the correct foreign phrase, and fix up the transcript from there.
Yeah, that's a great tip, Pete. We're getting quite a few questions today, which is fabulous. What are the primary things to look for in a voice-to-text technology? And I think that's a great question.
So here, I mean, if you think about those points I made earlier about how the data has been recorded and so forth, if you can, but I would say what would things that you should look for? Does the engine support your language? Does the engine support your industry? I think that's a really important one. How much work do you have to do? How much work do you have to put in to make it work? And how fast does it go? Well, depending if you have a ton of data and so forth. Yeah.
Okay, great. And what work, this is another question, but it certainly comes into that Australia, what work needs to be done to audio files prior to processing when the audio is stored in a proprietary audio codec? Now, I know we support, or Nuix Voice supports a large amount of audio files in different different codecs. So what about proprietary material, Pete?
You're right. We actually, I mean, Nuix Voice supports a ton of different formats, but I did have an example where it came in a very specific, it was a court reporting format, but I found a tool and just swapped it out into a normal, what was a WAV file in the end. It depends. If yes, we might find an audio file comes in that doesn't get supported, and it would be a matter of finding a way to convert it. If it's proprietary and someone says you couldn't convert it, well, that's what we deal with. But I've yet to see it. I've yet to see data that comes in, and we haven't been able to get it to a format that we can understand.
Great. Now, we've had someone else. Do you see in what ways do you see other organisations managing files? So obviously a lot of people are quite interested in the way different people are organising or managing audio files. So what are some of the experiences you've had, Pete?
I haven't really, I mean, audio files are kind of like it's a dirty little thing that you sweep under the carpet as far as I've been concerned. They might be sitting in a system at the back, but because, and I'm thinking here specifically about organisations that have large amounts of records, and because there's no real tools to really tackle them, they just put them to one side. So I haven't really seen much in the way. Actually, that's the kind of thing I'd love to hear more from people. You know, if people wanted to make comments and so forth on how they manage audio files, I'd be very interested to hear. It is, and it has been up to now, you know, a large problem to solve.
And that's a great point, Pete. If we can share that anonymously on this webinar, if people are faced with the challenges of audio, would like to share their experiences of how audio is being managed and stored within their organisation or what they've seen, please feel free to put it in the chat. We'll round back to this question and share a little bit of that anonymously with the group. We're still getting lots of questions, which is fabulous. So we've had another one. Does the system automatically flag transcription that it sees weird or not grammatically correct?
Yes and no. So the issue is that the standard software doesn't have tools to do that. What we've seen though is using scripts and so forth to go through in the background, and it's a fluid thing because you know trying to define what's weird and what's not is quite a difficult thing. So we have used custom tools to go through and identify those, but out of the box I'd say no. The software itself doesn't go through and say this is weird.
I guess this is where the advantages of having the text comes into it, Pete, that you can use other tools. You can set up grep, or you can perhaps start to look at visualization tools where show me all the phrases. I mean, you could probably start to pull out words and phrases that just aren't looking right, or perhaps short length words that look like they're anomalies. And the beauty of that then comes into the QA as well.
Oh, actually, that's a great point. You know, throwing in, you know, statistical approaches and machine learning against the text, natural language processing, because you've now got it in the text format, you can really start to throw some amazing analysis tools to identify that this thing is weird and, you know, should be looked at and closer. Yeah, good point.
Okay, we've had a couple around this, but this is from a particular close friend of Nuix. So can they field tune for specific words that aren't recognised and then add them to the dictionary?
So this comes back to that tool that I mentioned before about where we can do a text substitution, as it were. So we do call that field tuning, where we'll take the strange phrase and so forth, and we'll swap it out for what it should be. And the point is that gets applied then to the entire transcription. If we find that in a particular audio recording, and we'll apply that to the hundreds of thousands of hours that we've also processed for that particular project. So field tuning really is around taking those strange phrases, for example, swapping them out for what they should be, and then applying it to the rest.
Great. Okay, we've had a couple of questions around multiple speakers. So I'll pose it two ways. So can it differentiate between speakers in the transcript when it has multiple speakers, maybe two or more? And can it identify and tag transcript to an individual person if it's a group conversation? So I think that's sort of a two-pronged question there, Pete.
Yeah, it can, but there's a few things to remember. So in line with some of the customer sentiment analysis and so forth, the technology will actually go through and assign a gender to a person, and say, this is person one speaking, now it's person two, now it's person one, now it's person two. It does become a bit of a difficult problem. Typically when you've got an audio file, audio files comprise of separate channels, and you might think that a channel is, say, one microphone taking a feed in, as opposed to, say, if you had two people talking on the telephone, you've got two channels going in. So the software, if individual people are separated by channel, then it actually becomes not a difficult problem at all, because the audio for each is separated by the actual file format itself. But where you have something with, say, a background microphone, where you've got multiple people speaking, and you've got more than two people speaking, it just gets harder. It does its best by listening to the timbre of the voice, and obviously I obviously don't. If I sound much more manly than you, Ange, it's not. It's just because I have a deep voice and so forth. So that the technology listening to you and I speaking would identify you as female and myself as male. Hopefully, chances are we'll both come back as female, but that's okay too.
One can only hope. We have one last question that's come through, Pete. Thanks for that. Will Nuix Voice allow you to jump in time to the relevant part of the audio file by selecting a part of the transcript?
Yeah, absolutely. It's actually a really nice thing to manually listening to audio files and jumping around gets quite difficult because you lose track of where you are, but it's actually quite a nice thing that if you have the transcript popping up and it's divided by time slices and so forth, and you can leap down to where that piece of text is, and if you click on that text, it would have been a nice thing to actually have up, but you click on that piece of text and then it jumps straight to that audio and it starts to play. So if you were reviewing the text transcript, for example, and you see something that's really, really interesting or really, really strange, you just click on that and it jumps and the audio will start playing, and you can actually listen to that in the background. It's actually quite a nice workflow that's been designed.
Great. Well, I don't think anyone wanted to share how they're organising their audio files. I think you might be right there, Pete, that it's that dirty secret of the business record world that's sort of being swept under the carpet at the moment. So that was great. Thanks everyone for the questions. It certainly added to the discussion. There's certainly a lot of interest around this type of business record as it becomes more challenging for everyone. So thanks everyone for joining us today. We have just one last thought for everyone. Do you think it's time to improve your accuracy?